Okay, so for this example, we're once again going to determine, or actually show in this case, that the given function is a solution of the differential equation. And to do this, we want to first find the derivative so we know what we're looking for as a target. So when we take our y of t, you'll notice right away that it has the form of a quotient, but I wouldn't use the quotient rule here because that's a really heavy-handed way of doing it. Instead, I would use the chain rule. I'd rewrite it as 2 times c e to the negative 2t minus 1 raised to the negative 1 power. And then when I find my derivative, I'll just use the chain rule. So that's going to be a negative 2 c e to the negative 2t minus 1 to the negative 2 power, now times what's inside, which is negative 2 c e to the negative 2t. And it's very helpful to write this over again as a quotient, since that's how it started. So y prime is equal to positive 4ce to negative 2t over top of our ce to negative 2t minus 1 squared. All right, so the next thing we want to do is go in and verify the differential equation. And to do this, you always want to start with one side and show that it equals the other. And in this case, it's much easier to start with the complicated side and simplify it down to the smaller, simpler side. So we're going to start with our y times y plus 2, and now substitute in the y that they gave us. So the original y is 2 over c e to negative 2t minus 1. And then that's going to be times parentheses 2 c e to negative 2t minus 1 plus a 2. And now we're going to simplify this down. And it's a really good idea to get common denominators in the process of this. So we're going to have a 2 over c e to negative 2t minus 1 in front. And then when we get common denominators, we'll multiply the top and bottom by our c e to the negative 2t minus 1. So that's going to be 2 c e to the negative 2t minus 1 over c e to the negative 2t minus 1. Right, and then here, we can now add together these two fractions. We still have our 2 over c e to the negative 2t minus 1 out front. But when I add together, I have one common denominator of c e to the negative 2t minus 1. Then upstairs, I've got a 2. And then when I distribute that 2 in multiplication, I'm going to have a 2 c e to the negative 2t, and then a minus 2 behind it. And you'll now notice inside of my fraction that those 2's will cancel out. And now I can just multiply straight across. When I do that, I'm going to have my 2 times the 2 already there, which is 4c e to the negative 2t. And then down below, of course, when I multiply something times itself, I just get that quantity squared. So that's over c e to the negative 2t minus 1 quantity squared. And now if you look very closely, that is the same thing we got earlier for y prime. So we've shown that y times y plus 2 is equal to y prime. And therefore, we now have verified our differential equation. Very, very simple to do. Just have to make sure you're very careful with your calculus and your algebra. For the next video, we'll go through and solve the initial value problem, and then we'll state the interval of existence.